Hi, I'm Luke McKinney, Prep 101's instructor in Physics 101, and in this first video we'll introduce the core idea of scalars and vectors, then look at the vectors of displacement, velocity and acceleration, along with their scalar versions of distance and speed.
So the first physics term we want to deal with is the idea of a scalar and a vector. So we've got scalars versus vectors, which sounds like a kid's cartoon about snakes versus robots, but is slightly less exciting, being honest, slightly more useful. A scalar is just a number, whereas a vector is a number and a direction. And that direction has to be something that can be drawn in a straight line arrow. So round and round a bit wouldn't be a vector, but north or east or right or in plus x, those would all be vectors. Now numbers we've all met before. For example, if you have 1 kilogram of sugar, that's just a scalar. If you have a 100-watt light bulb, that's a scalar. If you have $10, ooh, that's a scalar. It's just a number with no direction. Even though it might always feel like it's going away from you, that's not a definite arrow. For vectors, however, that 1 kilogram, we'll see soon, has a 9.8 Newton force down. Or you might have a velocity of 20 meters per second east. And see, those have definite directions, and those are vectors. Now, most of those are clear, but what you want to watch out for is there's a couple of words in physics that are sort of muddy words in English, but have very specific meanings in physics. So we want to be specifically aware of them in case they come up, for example, in a multiple choice question. And those are: distance is a scalar, but displacement is a vector. Likewise, speed is a scalar and velocity is a vector. And those are pretty nice. You can see they alliterate. Speed is the scalar, velocity is the vector. And we're going to go on and see those in more detail right now. To look at displacement and distance, first we look at the idea of position, where we are, something we use in a lot of problems. You've got your current position and your old position, x0 or xo. And you'll see these things a lot. Sometimes x and x0 in one-dimensional problems. You might see or and or0 for position and old position. But you'd always just say the words, because you'll notice when you're solving problems, the exam problems and things don't say x and x0, they say this position and they start there. So if we have a new position and we had an old position, that means there was a change in position. So we can see that's a vector. We have a distance and a direction. And now the change in anything is always just the new value minus the old value. And we set that out in general because we use that in a lot of different parts of the physics course. So the change in position is the new position minus the old position. And that is a vector, the displacement. For example, that might be 10 meters to the right, like we just saw. Or if you just have the size of it, these two vertical lines just mean the magnitude of, which just mean take the size of it. That would just be 10 meters with no direction. And that's just a distance. And there's a couple of situations where that would be important. For example, let's imagine we had our little Mario. M for Mario. I can't draw very well, so there's a stick figure. Just standing on the edge of that area. Now, if Mario was suddenly to move 10 meters distance, well, that could go right or wrong. Literally right, he'd be okay. Left is wrong. And I can't do the sound effects. So you can see just 10 meters distance could be any direction, and not all of them work. So you could think displacement, he should go right. So the displacement is the distance and the direction. So that's the number and the direction, so that becomes a vector. Another example is, let's say we have somebody walking around a field, which is a square field 50 meters long. So if we start here and we just walk around the edges, we could be asked, what distance did we cover? And what is the final displacement? And those aren't the same thing. If we first look at the distance, well, we've moved 50 meters and 50 meters and 50 meters and 50 meters, because distance doesn't care about direction. So we've walked 200 meters. But what about the displacement? Well, displacement is the vector, the change in position, the new position minus the old position. But we see we've come around and our new position is exactly the same as our old position where we've started. So our displacement is 0 meters. Seems nice and clear when you lay it out, but you want to know that ahead of time. For example, if it was a multiple choice question and some of the answers were 200 meters or 0 meters, you'd always want to remember which was which. So remember, displacement, I should go that way. So displacement is the vector. The next pair of values is speed and velocity. And we can have a look at this. Velocity is the rate of change of position. And we can break this up. Velocity is, so the velocity is, we got the change in position, which we saw before, the change in position, and then the new bit, the rate of. Now the rate of change of anything is just that divided by the time taken. And we know any change is just the new value minus the old value. So if we want, we could write that as new position minus old position, new time minus old time. And writing out the basic formula like that will always help us work out the values. Now, we know position is measured in meters and time is measured in seconds. So velocity is measured in meters per second. And remember, velocity is a vector. Velocity is a vector, VV. So remember, that always has to have a direction. So we might have 20 meters per second north, or we might have 30 meters per second in the minus x direction. The x and y axes give us directions a lot. Usually, plus y is up, minus y is down, plus x is to the right, minus x is to the left. And we draw that to avoid any mistakes. So just as we have velocity is the vector, speed is the scalar. So it's just the size of the velocity. So it doesn't care about direction. So it can be 20 meters per second. So if you're going at a speed, it doesn't matter if you're going up, down, left, or right, or anything like that. The final concept in this first primer is the idea of acceleration. And this is another one we have to look at a bit because it has a sort of casual meaning in conversational English, but physics is a bit more precise. And in a physics exam, of course, it's the precise meaning you'll need. Now, acceleration is the rate of change of velocity. So just like the last one, we can put it together. Acceleration is the change in velocity and it's the rate. So that's divided by time. Throughout the course, we'll always see the rate of something is just that divided by time. So we have new velocity minus old velocity, new time minus old time. And we always say out the full words. You'd be surprised at how much difference that makes in doing all the questions in exams, how it makes the things much easier to deal with. Now, looking at units, velocity is meters per second and time is measured in seconds. So you've got a fraction over a fraction, meters per second over seconds. And with a fraction like that, you just put the bottom line down on the bottom. So you've got meters per second squared. Now there's a little key thing here about the acceleration. It's to do with changes in velocity. Now conversationally, we think of acceleration as getting faster, and that is a change in velocity. But acceleration deals with any change in velocity. So speeding up is an acceleration. Slowing down is also an acceleration. It's just an acceleration opposite in direction to the velocity you're going. And changing direction is also an acceleration. Because remember, velocity is a vector. It has a size, so changing the size is an acceleration, and a direction. So changing the direction is also an acceleration. And we'll see that as a key idea in the circular motion, for example.
I hope that was useful. There's plenty more useful videos in the playlist and even more useful exam style practice and tips and all sorts of things in the prep sessions. So make sure you join the Prep 101 Facebook Study Hub. You'll find out about everything we're doing there when the prep sessions are on, and there's even sometimes free ones, so you don't want to miss those. Hope I'll see you there.